Hello everyone. As you can see, it's section 3.2 and we're still sticking with solving systems. Let me switch colors. Your goal is still to find the coordinate where the two lines touch, but as you guys saw with graphing, it was a bit of a drag to always have to graph it and to get it to work, and it was all subject to how well you could draw the lines to how accurate your answer would be. So what you'd like to do is get away from having to graph these things to do it. Now, unfortunately, that means that y'all going to have to do some algebra to do it. What you need to keep in mind when you're doing these is you're looking for the coordinate where the two lines touch. Assuming that's true, this x is exactly the same y, or sorry, this x is the same x in both of them, and that y is the same y in both of them. So if in this equation your y is worth this much, and in the other equation the same y value is worth this much, then these things have to be equal to each other. X minus 4 is equal to 3x plus 6. The logic that I'm using is if A is equal to B and B is equal to C, then doesn't A have to be equal to C? Same thing here. If y is worth this much and y is also worth that much, they have to be equal to each other. Okay? And I need to solve from there. So how about I cut the x off of both sides? So I have negative 4 is equal to 2x plus 6. Subtract the 6. Negative 10 is equal to 2x divided by 2. And you've got an x value that would be negative 5. Now, I still have to find the y value. But if I know x is negative 5, how about go and fill it into one of the equations? And you'd have y is equal to negative 5 minus 4, so y is equal to negative 9. And if I've done it right, it's not going to matter which one I fill it in. So if I fill it into the x of the other equation, y is equal to 3x plus 6, and fill the same negative 5 into it, y is equal to 3 times negative 5 plus 6, that's negative 15 plus 6, you still get negative 9. It's not going to matter which equation you fill it in. Why? Because this is a coordinate that they both share. You've got the two lines, they're sharing the same coordinate. So it should be the same in both of them. And that method that I just did is I did substitution. I let one y value substitute for the other. That's one style of the question you could be given. Another style, another format, another way it could look is like this, where one of the letters is solved for and the other one it's not. You could turn this one into y is equal to negative 2x plus 9 by subtracting the 2x to the other side, and then using these two to do it just like I did here. X plus 3 is equal to negative 2x plus 9. Or what they're really is suggesting that you do on this one instead is that here's a y value and there's a y value. Those y values are equal. So substitute one for the other. So in other words, 2x plus something that's a y value is equal to 9. And in there I'm going to fill in what y is worth. Y is worth x plus 3. So now I've got 2x plus 3 is 9. So I have 3x plus 3 is 9. Subtract the 3. Divide by 3. X is 2. If x is 2, y is 5. Okay? That's how they're intending you to do it. Substitution, by substituting in this way. But the method you used in that one is still viable. I'm just giving you the whole picture here. Keep in mind as we do these, your goal is to find out where the suckers touch. Where do the lines cross? What is the coordinate of where the two lines are crossing? So keep that in mind as we keep going through this. So here's what y is worth, and there's a y value. X minus whatever the y value is worth. I'm strongly recommending you guys write it like this. Take the other equation, write the whole thing, put a variable in place of the y. because if you don't, you're going to run the risk of losing pieces of information, and I'll coach you on that as we go. So I just filled in what y was worth in this equation right here. This subtraction sign is still out there. Now you have to go back and distribute the subtraction through both things. X minus 2x plus 1 is equal to 4. So I have minus x plus 1 is equal to 4. Subtract the 1. Whoops, positive 3. Sorry about that. Getting ahead of myself. X is equal to negative 3. So that's the x value of your coordinate. Now you can go back and you can fill it into either equation. That one's going to be the easiest. So it's negative 6 minus 1, so negative 7. Okay, that's the coordinate where they cross. You could fill the x into the other one, the negative 3 into this equation, and make sure you get the right answer. It would be a check to fill it into both of them and see if you get the same y value. But in the interest of this video for you guys, I'm going to let that slip. Same thing, here's a y value, fill in what the y is worth, but I'm strongly recommending that you guys write it like this. Go and fill in what the other y value is worth inside the parentheses, so you don't lose anything. So then you have x plus, 8x plus 6 is equal to 24. 9x, I'm going to subtract the 6 off, equals, what would that be, 18? So x is equal to 2. Take the 2 and fill it in, and be easiest in this one, 8, 11. Again, you could check by filling it into the other one to see if it worked, by filling it in right there. Once again, it's your call. This is actually the one this equation is the one that's going to be easiest to solve for y. If I pull the 3x over on this one, because let me back up. I guess I assumed you knew what I was doing, and I shouldn't do that. In each of these equations that you've had so far, one of them has been solved for y. Here's one where neither of them is solved for y. So I need to get one of them to be solved for y. You need to get it a y equals, so you can do the substitution process. I think this one is the one that's easier to do it to. I'm going to subtract the x over. Do you have to do it to the bottom one? No, it's an option. It's your call, you're in charge, you do it. Then you're going to substitute. If you solve the bottom one for y, then you have to fill it in to the upper one. 3x minus whatever y is worth is equal to 8. Go and fill in what it's worth. Minus x plus 4, and then solve it from there. Find the x and the y from there. In the interest of time for you guys, I'm just going to skip that part. Okay? I think you get the idea. If you really want to see that distributed through, maybe I should. Maybe I shouldn't be in such a rush. 3x plus x minus 4 is equal to 8. How about I just quit there and say, okay, you guys can get it from there. But you're distributing this subtraction through both things. Okay? This bottom one again is going to be the one that's going to be easiest to solve for y. Oops, forgot the minus. I'm going to fill it in for the y up here. And you get 5x plus 2 minus 3x plus 2 equals 5. Distribute the 2 inside. 5x minus 6x plus 4 is equal to 5. So then you have minus 1x plus 4 is equal to 5. Subtract the 4. Get rid of the negative 1. So x is equal to negative 1. And then fill that x back into either equation and solve for y. Yep, it's going to be a little bit harder on these. I think this one's going to be easiest one to fill it in. Or hey, how about in that right there? But I would suggest fill it into the original, but you know, it's your call. Trying to get kids to fill it back into the original usually is a little hard. So the reason I'm recommending that is because if you made a mistake from here to here, you know, I'm not saying it'll catch it, but I guess I'm just being old-fashioned and wanting to stick with it that way. So filling it in, putting a negative 1 in there. So that's 3 plus 2 is 5. So there you go. Okay, trying this one. I think this one's going to be easier if you pull the x over. So you have y is equal to negative x plus 4. Taking this, filling it into 4y in the other one. So then minus x plus 4, 2x, whoops, how about I erase? 2x minus 2x plus 8 is equal to 8. Well, you're left with 8 is equal to 8. How often does that happen? Always. 8 is always equal to 8. Now remember back, you could have a graph where you had two lines that crossed in one specific location. You could have a graph where they never touched. Remember? This was no solution. But then you could have one that was the same line over top of itself. That's what this means, because your goal is to find out where they touch. What's the coordinate? Well, this thing is always true. 8 is always equal to 8. Or, say you have a different problem in your homework, 2 is equal to 2, or 0 is equal to 0. Those are all true 100% of the time. So where are they touching? They're touching everywhere. You have infinitely many answers when you get a true statement like that. So what you should be thinking ahead is, if you get a false statement, that means no solution. That means this example right here. The lines are parallel, they don't touch. So how about this? I'm going to pull the 2x to the other side. 2x minus 3. There's what y is worth. Here's y. Minus 2x plus equals 4. Fill in what y is worth. 2x minus 3 from up here. Negative 3 is equal to 4. How often is that true? Never. That's never true. So, no solution. It's this situation. Okay? So that's substitution. Showing you guys a different way is by linear combination. Linear, because they're lines. Combination, because you're going to combine them together. If I just added these things together, notice I get 4x plus 0y is equal to 12. Or, better yet, 4x is equal to 12. One of the variables disappeared, and that's important, because then you can solve for the one of the variables. So I got an x value of 3. Go back, fill in that x is 3, and you get y is 1. 3, subtract the 3 over y is 1. So the idea is you're going to combine these in such a way that one of the variables cancels out. It's not important that it's going to be the y's. It could be the x's that cancel. So let's try this one. You're looking to combine these in such a way that one of the variables disappears. I'm going to take this bottom equation, and I could do it to the top. You'll get more comfortable with this as we go. And I'm going to multiply the negative 1 through. I'm going to rewrite the top. 2x plus 3y is 6. I'm going to multiply the bottom all by negative 1. And now I'm going to add them together. And look what happens. The x disappears. 7y is equal to 14. Y is equal to 2. So you've got your part of your coordinate. Take the y value, fill it back in. Doesn't matter which equation, because if you did it right, it'll work out. 2x plus 6 is equal to 6. Subtract the 6. X is equal to 0. So your coordinate where they touch is 0, 2. Okay? And what you're noticing is, for these things to work, one of the variables, the coefficient, the number in front of the variable, has to be the same number but opposite in sign. Same number, opposite in sign. Doesn't matter if it's the y's or the x's, but you need one of the variables to have coefficients, same number but opposite in sign. So here, what would be easy is if I multiplied all the bottom by 2. 2x minus 8y is equal to negative 24. Now when I combine it with the top one, the x's disappear because the coefficient on the x is opposite in sign and the same number. So minus 2x and 2x is nothing, and there's no x's left. 3y and minus 8y is minus 5y. 14 minus 24 is negative 10. Y is equal to 2. So you got your y value. Fill it back in to find your x value. I think you guys can get it from there. And here, you're making a choice. You could either make the y's disappear by multiplying the top all by 2, or you can make the bottom disappear by multiplying the bottom all by 3. It's really your choice. There isn't a right way and a wrong way to do it. Sometimes there's an easier way, but there is never going to be a right way. 18x minus 8y is equal to negative 36. Leave the bottom alone. Add these things together. 15x, those cancel out, is negative 30. So x is negative 2. So negative 2 is your x value. Go back, fill in this x value into one of the equations, and solve for y. Again, in the interest of time, I'm going to let you guys have that part of it. Looking at this one, there really isn't one that's going to be nice to combine. Like here, I just had to multiply the top to get the coefficients there to match, or in opposite in sign. Here, it's not going to work so much. These are opposite in sign, so I'll go for the y values, but the smallest number, it's like a least common multiple is what you're looking for, would be 12. So I'm going to multiply the top by 4, and the bottom all by 3. And notice I don't write on it, because when you go back to fill a number in, if you've written all over the sucker, you have a really hard time seeing what numbers are supposed to be there. So I'm strongly recommending that you guys take a second and just rewrite it. So plus 12x, 12y is equal to 48. Sorry, that's 4. 9x minus 12y is equal to 3. So that's 17x. Those are gone, and that's equals 51. And when you divide that by 17, I believe you get 3. So x is 3. Go back, fill in your x value of 3. In case you guys aren't sure what I mean, and I think you do, but you know, I guess I'll do this one. So I'm going to fill that in for 3. So that's 6 plus 3y is 12. Subtract the 6. 3y is equal to 6. Divide by 3, and you get y is 2. So your y value is 2. Okay, that's what I mean. Go back and fill it in. So once again, if this is bugging you on this idea of multiplying both equations by something, I'll do another one. I'm choosing to do it to the y's because they're opposite in sign. There's nothing that says I have to start there. That's just a choice that I'm making. The least common multiple is going to be 20, so this gets a 5, and this gets a 2. Whoops, why did I say 2? I have no idea. Gets a 4. Sorry about that. So 15x plus 20y is equal to negative 30, and this one is 8x minus 20y is equal to, if that would be 20, it'd be 80, so 76, I think. 23x equals 46. So then divide by 23, and x is 2. Take that x, fill it back into either equation, and solve for y. Alright? I think that's the last page. Yep, it is. Thanks, guys, for your patience, and I hope this works well for you. Let me know.